Okay, in this video we will talk about adding and subtracting rational expressions. Okay, so we can add or subtract rational expressions as long as they have the same denominator, right? So p over q plus or minus r over q, this addition or subtraction can be performed because the denominator is the same. And here I have p plus or minus r as numerators. Okay, so bringing the expression under common denominator is the place where students make the most mistakes. Okay, but before we go there, let's just do an example where the rational expressions have the same denominator. So let's say that we want to simplify the expression 2x squared plus 10x plus 3 over x squared minus 36 minus x squared plus 6x plus 5 over x squared minus 36 plus x minus 4 over x squared minus 36. Okay, because here the denominators of the three rational expressions are the same, we can just simply rewrite the denominator right here, x squared minus 36, and then just add these three numerators. So that's 2x squared plus 10x plus 3 minus x squared plus 6x plus 5 plus x minus 4. So here on purpose I made a mistake, and this is the most common mistake that the students do, is that they forget yet again the parentheses. Okay, so this minus is in front of the whole fraction. Doesn't mean that x squared is negative. This minus multiplies the whole denominator, which means that on this step I have to use this parenthesis. How that is going to change this expression? Well, once you drop the parentheses, so 2x squared plus 10x plus 3, once you drop the parentheses, again this minus sign multiplies every term within the parentheses. So that's negative x squared minus 6x minus 5 plus x minus 4 over x squared minus 36. Now let's simplify the expression let's simplify the numerator, okay, because there are many like terms. So let's see, where are they? So I have 2x squared minus x squared. Well, 2x squared minus x squared is just x squared, right? I have 10x minus 6x, that's 4x, plus 4, that's 5x. So plus 5x. And finally, the constant 3 minus 5 is negative 2, minus 4 is negative 6. So minus 6 over x squared minus 36. Okay, now of course we have to continue thinking whether we can simplify this expression, meaning whether we can cancel something. Okay, right away the easiest thing to notice is that the denominator is difference of squares, so that's x minus 6 times x plus 6. And what did I say in the previous video? You can see that the way we think is I will be able to cancel this denominator and this numerator as long as they have common factors. So the denominator has factors x minus 6 and x plus 6. So if the numerator has one of these two factors, then we can cancel. So let's check whether the numerator has the factor x minus 6. That means, in other words, whether the numerator is 0 when you're going to plug x for 6. X squared is 36 plus 30 is 66 minus 6 is not 0. Okay, so x minus 6 is not factor of the numerator. Maybe x plus 6 is neither, so let's check that. The numerator will have a factor of x plus 6 as long as negative 6 makes this expression here 0. So negative 6 squared is positive 36 plus 5 times negative 6 is negative 30. 36 minus 36, 6 minus 6 is 0. So definitely I have a factor of x plus 6. Okay, so let's finish factoring this numerator. I'm multiplying x by x to get x squared, and I'm multiplying positive 6 by negative 1 to get negative 6. And the common term, we can cancel the common factor. So I get x minus 1 over x minus 6. Okay. So things get slightly more complicated when the denominators are not the same. In that case, we have to find the least common denominator, okay? So if the denominators are relatively prime, which means if they don't have common factors, then R over S. So if Q and S, they don't have common factors, then we just the least common denominator is going to be the product of these two. Okay, so here I'm going to put Q times S, and here the question is, well, what are we going to have here, right? Well, how I can bring P over Q to be equivalent expression, or find the equivalent expression of P over Q that will have denominator QS. Well, if I multiply this expression by 1, I'm not going to change its value, right? So I'll get 1 if I multiply it by S over S. And how do we multiply rational expression? That's actually the easiest operation with rational expressions. You multiply numerator to numerator, P times S, denominator to denominator, which is Q times S. Okay. Similarly, R over S times, now I want to find the equivalent expression to R over S, but having denominator QS. So I'm going to multiply it by Q over Q. I'm not changing its value R over S because I'm multiplying by 1, so this is RQ. Okay, so P over Q plus or minus R over S is the same as P times S plus or minus R times Q. And now it's very important to remember again where Q and S don't have common factors. They're relatively prime. Okay, so for example, 1 over x minus 1 over x minus 3. Okay, so be careful. This whole thing is the factor, right? So x by itself is not a common factor. So because these two are relatively prime, the common denominator is going to be x times x minus 3. So what will I have in the numerator? Well, what is 1 over x? With denominator x times x minus 3. Well, if I just multiply this by x minus 3 and divide it by x minus 3, then I'll get the same expression, right? The same value. 1 times x minus 3 is just x minus 3 over x times x minus 3. So 1 over x becomes x minus 3 over this minus 1 over x minus 3 is the same as, well, if I want to express this rational expression with different denominator x times x minus 3, how to get there? Well, I multiply the denominator by x, but simultaneously I have to multiply the numerator by x. So I get x here. So minus x over x times x minus 3. And now these two rational expressions have the same denominator, so you can write it like that, and you have x minus 3 minus x. At this point you can just cancel the x's in the numerator, and the answer is negative 3 over x, x minus 3. Okay, so what happens now, the most difficult case, what happens when the denominators are not relatively prime? Okay, how to find the least common denominator? Okay, maybe you have seen this in high school. LCD stands for the least common denominator, and is the product of all the factors with highest power. Okay, so for example, if I want to add x cubed, x plus 2 times x minus 3 minus 1 over x times x plus 2 squared. Okay, don't make the mistake to jump into writing the common denominator as the product of all the factors. The least common denominator is not product of all the factors, but the product of the factors with highest power. Okay, so here I have x cubed, and here I have the factor of x. So that means that here I'm going to take x cubed as the highest one. Here I have x plus 2, here I have x plus 2 squared. So in the least common denominator is going to be x plus 2 squared. And finally, here I have x minus 3, so I have to take that one, x minus 3. Okay? Now, what 1 is going to become if I change this denominator into this? Okay, so what has changed? X cubed stayed x cubed, x minus 3 stayed x minus 3, but x plus 2 is written as x plus 2 squared. That means that I have multiplied the denominator by one factor of x plus 2. If I multiply the denominator by x plus 2, I have to multiply the numerator by x plus 2 minus. By similar logic, this x became x cubed. That means that I have to have multiplied this x by x squared. I cannot just multiply the denominator by x squared. I have to multiply the numerator by x squared as well. So 1 times x squared, again use the parentheses. X plus 2 squared is x plus 2 squared, so we haven't changed that one, so we are not going to multiply by factor of x plus 2. And finally, out of nowhere, x minus 3, the factor x minus 3 showed. So that means that I have multiplied this factor by x minus 3. If I, the denominator by x minus 3. If I multiply the denominator, I have to multiply the numerator by x minus 3. So, and then you can open the parentheses, minus x cubed plus 3x squared over x cubed, x plus 2, x minus 3. So this is negative x cubed plus 3x squared plus x plus 2 over x cubed, x plus 2, x minus 3. And you can check whether is it possible to simplify this expression by checking whether either 0, negative 2, or 3 makes 0 in the numerator. If you plug 0 here, 0 plus 0 plus 0 plus 2 is not 0, so which is obvious, I cannot factor x. Negative 2, negative 2 cubed is negative 8, times negative is positive 8, plus 2 is 10, minus 2 is 8, okay, and here I have 4 times 3, which is 12, so we don't get 0, so x plus 2 is not factor of this numerator. And similarly with positive 3 plus 5 is 2, 9 times 3 is 27, plus 5, 32, which doesn't cancel out with negative 3 squared. So I cannot factor out the numerator in a way that I'll get either x plus 2, or x minus 3 as factors. So I'm not going to continue factoring, so I'm not going to continue simplifying this expression. Okay, usually what we have to do, let's do another example. So here, for example, in this example, the denominator should be factored, but usually that's not the case, so let's do one last example. X over x squared plus 4x plus 3 minus 3 over x squared minus 4x minus 5. Okay, so we have to first factor out these two denominators. Okay, either use the factor theorem, or if you don't use the factor theorem, then find these two numbers p and q. So I'm factoring this denominator here such that p times q is equal to 3 and p plus q is equal to 4, and obviously that's 3 and 1, right? 3 times 1 is 3, 3 plus 1 is 4. So the first denominator can be factored out as x plus 3 times x plus 1 minus. Now it is slightly easier. We are hoping that one of these two factors is here. Okay, so let's try with negative 1. Negative 1 squared is 1. Negative 4 times negative 1 is 4. 1 plus 4 is 5, minus 5 is 0. So this factor has, this denominator has the factor x plus 1, and now finish factoring the denominator. That's x minus 5. Okay, so obviously these two denominators have the common factor. So the common factor is x plus 1, okay, in both cases. So I'm taking as a common denominator the highest exponent, the highest power of each factor. So that's x plus 3 times x plus 1 times x minus 5. Okay, so this denominator differs from this denominator by the factor of x minus 5. That means that I have multiplied the denominator by x minus 5, but if I do that, I have to multiply the numerator by x minus 5 also. Okay, minus 3, the difference between this denominator and our new denominator is the factor of x plus 3, so I have to multiply this one by x plus 3. And from here, we just expand the numerator and simplify if possible. So x squared minus 2x minus 9 over x plus 3 times x plus 1 times x minus 5. Okay, and I made a mistake here. I'm sorry, because x times x is x squared, but x times negative 5 is negative 5x. Negative 5x minus 3x is negative 8x. Sorry about that. So now again, if I want to cancel the numerator and the denominator, the numerator has to be written as product of factors, one of which is going to be either x plus 3, x plus 1, or x minus 5. So let's check the smallest one, and let's hope that that solves the problem, whether x plus 1 is a factor of this polynomial. If x plus 1 is a factor of this polynomial, that means negative 1 will give me 0 if substituted for x. Let's check. Negative 1 squared is 1, minus 8 times negative 1 is 8, 8 plus 1 is 9, 9 minus 9 is 0. So definitely x plus 1 is a factor of this polynomial. Finish factoring x minus 9, and here we have x plus 3 times x plus 1 times x minus 5. Cancel x plus 1, and we get x minus 9 over x plus 3 times x minus 5.